In our previous video, we have completed all the connections in our PCB layout. In this video, I am going to talk about copper pores. Copper pore is an area filled with solid copper. In most cases, copper pore is used to create a ground plane. Copper pore is also used to create power planes. If you use copper pores in your PCB, you should be careful about two things. One is clearance and another is thermal relief. Clearance is the spacing between copper pores and vias. By default, copper pores will have the same clearance as we defined in our constraint manager. If you want higher clearance, you can set that in shape parameter menu. The other important thing I want to talk about is the contact type. In this figure, you can see two types of contacts. On the left, you can see full contact, and on the right, you can see orthogonal contact. On the left, the component pad is entirely connected to the copper pore. This is called full contact. This contact is good if you want minimal inductance in the component connectors. This contact is also good for higher current rating. On the right side, you can see that the component pad is not entirely connected to the copper pore. This is called orthogonal contact. The component pad is only connected with 4 spokes to the copper pore. This type of contact is good for soldering. In case of full contact, when you apply heat to the pad, the heat spreads out throughout the entire copper pore. But in case of orthogonal contact, the heat does not spread out as much as full contact. According to your application, you have to choose between these two types of contacts. Let's see how we can change the shape parameter. Go to Shape, Global Dynamic Parameters. You can change type of fill. You can control the voids here. If you select individually, then the void will be like this. If you select inline, the void will be like this. The clearance, by default, the clearance of copper pores to through pin, SMD pin and via is the DRC. You can add some oversized value here. If you add something here, then the clearance will be DRC plus this value. I'm not going to change this right now. Here you can change the type of thermal relief contacts. If it is orthogonal, the component pad will be connected with some spokes. If you make it full contact, then the component pad will be connected entirely with the copper pore. For now, I am going to keep it orthogonal. Now I want to place a copper pore for ground plane in our second layer. To do that, select this rectangle icon. Here select Edge. In this box, select the layer. I want layer 2. Here you have to assign the net name. Select this icon and our ground plane name is 0. Click OK. And here you can draw the rectangle. Right click and press done. If you zoom in, you can see that here with this pin, our ground plane made a connection. Our ground plane made a connection with this pin as well. This pin, this pin, this pin and this pin. And our ground plane is not connected to any other pins. Now, as we already used a copper pore for our ground plane, we don't need this trace on the top layer for ground net. So I'm going to delete this ground net on the top plane. You can do that by pressing this delete icon. I am deleting all the ground nets. As I have deleted the ground nets, I don't need this via. I'm deleting that via as well. Right click and press done. I want to define another layer for our positive power supply. We can do that in the same way. Select this shape, add rectangle icon. Select layer 3. Select the net, that is V+. Press OK. Draw the rectangle. Right click, press done. As we defined another layer as our positive power supply, we don't need this copper net on the top layer. I'm going to delete this V+ net from top layer. You can define another layer for the negative power supply. Let's do that. Select shape, add rectangle. Select S, select layer. Select the net, V-, select OK. Draw the rectangle. Right click and press done. As we defined our negative power supply in another copper plane, now we don't need this V- net on the top layer, so we can delete this net as well. Here I have defined 3 layers for ground, positive power supply and negative power supply. You don't always have to define the entire layer as any single net. You can define a specific region as one net, and you can define another region of the same layer as different net. Okay. Now let's place some screw holes for mounting purpose. Go to place, manually, go to advanced setting, select library, go back to placement list. In this box, select mechanical symbol. Select this MTG125. This is for standard number 6 screws. Place the screw holes. I am placing again. I need another, and the last one. Okay. I'm going to move the screw holes to align properly. Here the screw hole is interfering with this connector. I'm going to move this connector a little bit left. Okay, done. In this video we have learned how to use copper pores, how to change different parameters of copper pores, and how to place mechanical symbols for screw holes. In the next video I will show you how to change the text to be printed on the silk screen. Thank you.